Right, in this video we're going to try and find the full solution of the second derivative minus the first derivative minus 6y is equal to some function of x, which we're going to call x squared in this case. So this is of the type a second derivative plus b times the first derivative times c times y is equal to some function of x. Up to now we just solved them where this has been equal to 0. Right, the solution will consist of two parts. The complementary function, which we call CF, and the particular integral. And we need to find both of them in order to solve the differential equation. So therefore, to solve the second derivative minus the first derivative minus 6y is equal to x squared. For the complementary function, we do what we've done before, which we just solved now for the second derivative minus dy by dx minus 6y is equal to 0. We just ignore the x squared on the n. So to do that, we let y be equal to mx. Differentiate that, we get me to the mx. Differentiate again, we get m squared e to the mx. Now substituting this into our differential equation with equal to 0, we're going to get m squared e to the mx minus m e to the mx for the first derivative minus 6 times e to the mx, and that's now equal to 0. Right, there's a common factor of e to the mx that comes out, and we're left with m squared minus m minus 6 is equal to 0. This is called the auxiliary equation, because this can't be equal to 0 because it's always positive. Therefore, m squared minus m minus 6 is equal to 0. If we factorize that, we're going to get m minus 3m plus 2. And therefore, m will be equal to 3, or m will be equal to minus 2. Therefore, our complementary function is going to be y is equal to a e to the 3x plus b e to the minus 2x, where a and b are arbitrary constants. Okay, so the next bit is we need to find the particular integral, pi. As f of x is equal to x squared, the bit on the end, you need to try y is equal to vx squared plus mu x plus lambda. So if we take our guess, this one, and then differentiate it, we differentiate this, we get 2vx, differentiate this, we get mu, nothing from the constant, and if we differentiate again, we're just going to get 2v. Now we substitute this into the given differential equation with f of x on the end. So the second derivative minus the first derivative minus 6y is equal to x squared. So we're going to do 2v minus 2v plus mu minus 6vx squared plus mu x plus lambda is equal to x squared. So, sorting that out by expanding the brackets, so we get minus 2vx minus mu minus 6vx squared minus 6 mu x minus 6 lambda is equal to x squared. So of x squared, we're going to have minus vx squared, and then for the x's, we're going to have a minus 2v plus a 6 mu of x, and then for the constant term, we're going to have 2v minus mu minus 6 lambda is equal to x squared. So writing that out again, what we do now is we equate coefficients. So what we say is minus 6v is equal to 1x squared. So for x squared, minus 6v is equal to 1, that gives v is equal to minus 1/6. And then for x, we're going to have minus 2v plus 6 mu is equal to 0, because there is no x on this side. We can forget about the minus sign and say that 2 times my value of v, minus 1/6, plus 6 mu is equal to 0. So 1 minus 1/3, doing that, is equal to So minus 1/3 is equal to minus 6 mu, and therefore mu will be equal to 1/18. For the constant term, 2v minus mu minus 6 times lambda is equal to 0, because there is no constant term on this side, so it's equal to 0. So I've got the value of v and mu, substitute in, so we get 2 times minus 1/6 minus 1/18 is equal to, taking that over there, 6 lambda. Working this out, we're going to get minus 1/3 minus 1/18 is equal to 6 lambda. Then minus 7 over 18 is equal to 6 lambda, and lambda will be minus 7 over 108. Therefore, the particular integral will be minus 1/6 of x squared, my value of v, plus my value of mu, 1/16 of x, plus my lambda minus 7 over 108. Y is equal to the complementary function plus the particular integral, so that y will be ae to the 3x plus be to the minus 2x, and then my particular integral, I need to add on minus 1/6 x squared plus 1/18 x minus 7 over 108. Okay, so this has been a video to show you how to solve a second order differential equation by finding both the complementary function and the particular integral. I hope you've understood, and I thank you very much for watching.